You built a regression model in the recipe lab. It has coefficients, p-values, and an R-squared. But is the model actually correct? A patient can have normal blood pressure and still have heart disease. A regression can have a significant p-value and still be fundamentally wrong. The health checkup, Regression Diagnostics, catches problems that summary statistics hide. A residual is the difference between what you observed and what the model predicted. Observed minus predicted. If the model is good, residuals are random noise, no pattern, centered at zero. If the model is bad, residuals have structure, curved trends, clusters. The residuals contain everything the model missed. Reading them tells you what's wrong. What residuals on the y-axis against fitted values on the x-axis. A healthy model shows a random horizontal band centered at zero. A funnel shape, residuals, spreading out as fitted values increase, means heteroscedasticity, the variance of the errors isn't constant. A curved pattern means the relationship is nonlinear and you fitted a straight line. These are the most common diseases, and this one plot catches both. Plot residuals against each predictor variable separately. If the model correctly captured the relationship with CWRES, residuals should show no pattern against STIS. A U-shape against TIS means you need a quadratic term, t squared. A trend against cis that isn't in the model means cis should be added. Residual versus predictor plots reveal missing terms. They're the diagnostic that tells you which variables need more attention. The QQ plot checks whether residuals are normally distributed. Plot the quantiles of your residuals against the quantiles of a standard normal distribution. If residual are normal, the points fall on a straight diagonal line. An S-curve means heavy tails, more extreme values than normal predicts. A bend means skewness. Departures from the diagonal tell you the distribution of the errors isn't what you assumed. For linear regression with normal errors, this matters for inference. For GULMs, use deviance residuals instead. The scale location plot checks if variance is constant across the range of predictions. Take the square root of the absolute standardized residuals and plot against fitted values. A flat, horizontal trend means constant variance, homoscedasticity. A rising trend means variance increases with the predicted value, heteroscedasticity. If you see heteroscedasticity, your options: log transform the response, use weighted least squares, or switch to a GULM with a variance function that models the changing spread. Residuals versus fitted catches nonlinearity and heteroscedasticity. Residuals versus predictors reveals missing terms. QQ plot checks normality. Gay location checks constant variance. 4 plots, 4 vital signs. Next, the one data point that changes everything.